Hello everyone. This is part 3 of the chapter Force and Pressure. If you haven't watched part 1 and 2 of this chapter, I recommend you to watch it. The links are in the description below. There are two types of pressure, liquid pressure and gaseous pressure. Liquids and gases are called fluids. Fluids mean that they can flow. Let's first discuss liquid pressure. Liquid pressure exerts pressure in all directions such as upwards, downwards and sideways. The sideways pressure at the same depth is equal in all directions. As the depth increases, so does the pressure. And the pressure of liquid at the base of the container increases with the increase in volume of the liquid. All liquids exert pressure. Now let's discuss gaseous pressure. All gases exert pressure because they are always in motion. They are always in motion means that their molecules are actually always in motion. If gases are confined in a container, the molecules of the air exert pressure on the walls of the container in all directions. When we fill air in a balloon, it gets inflated. It gets inflated because of the collisions between the molecules of the air and the inner surface of the balloon. If we fill too much air in the balloon, it bursts. It bursts because the thin layer of the balloon skin eg- can hold a certain extent of the pressure, but if the pressure, that is of the air, increases more than that extent, it gets bursted. Atmospheric pressure. Atmospheric pressure exerts a great amount of pressure on all objects. Atmospheric pressure is a type of gaseous pressure or air pressure. The earth is surrounded by a blanket of air called the atmosphere. This atmosphere exerts a large amount of pressure on Earth and the objects on it. Atmospheric pressure decreases with increase in altitude and increases with decrease in altitude. Near the sea level, the atmospheric pressure is the greatest because the column of the air pressing on us is the highest and the longest. Since air has weight, even it exerts pressure. The atmospheric pressure at the sea level is 760 millimeter of mercury. Now let's discuss why do airplanes have round windows. Airplanes have round windows because sharp corners naturally concentrate more stress, which further gets weakened by the immense air pressure. Curved or round windows distribute the stress of the outside pressure of air and thus are stronger and prone to deformation because of the pressure. Now let's see why do cylinders, that are LPG cylinders and oxygen cylinders, have rounded edges. Gas bottles are cylindrical or spherical because circular hoops can withstand internal pressure by pure tension in the tank material instead of bending. If the shape were not circular, then there would be bending stresses in the tank wall and it would not be able to withstand as much pressure without breaking. Now let's see why do astronauts wear spacesuits in space. The pressure created by the air and the internal pressure created by the blood pressure on Earth is constantly in balance. As there is no air in space, there is no air pressure in space too. Therefore, spacesuits are inflated with a certain amount of air, just like a balloon, to apply the necessary external pressure to the astronaut, allowing the body to be normal. We also are not crushed by the atmospheric pressure because of the blood pressure that is exerting outwards. The both are so finely balanced that we don't even feel the atmospheric pressure. We feel the atmospheric pressure only when we go to high altitudes or in deep mines. In high altitudes, when the pressure is lower, the blood pressure bursts the thin arteries, and so blood comes out. Atmospheric pressure plays a very important role in our lives. For example, when we drink juice with a straw, the atmospheric pressure helps to push the liquid into the straw, which then goes into our mouth. In a rubber sucker, the atmospheric pressure pushes on the convex surface of the rubber sucker, which binds it to the flat surface. In a syringe, atmospheric pressure plays a role to send the liquid into the body of the syringe. In a dropper, atmospheric pressure is what sends water through the nozzle into the glass tube when we press the rubber bulb. There are many activities to see liquid pressure. The first one is liquid pressure increases with increase in depth, and the second one is liquid pressure stays same in equal depth. Instruments to liquid pressure is a manometer. Instruments to measure gaseous and atmospheric pressure is a barometer. Otto von Guericke, a German scientist of the 17th century, invented a pump to extract air out of a vessel. It was the vacuum pump. With the help of this pump, he demonstrated dramatically the force of the air pressure. He joined two hollow metallic hemispheres of 51 centimeters each and pumped air out of them. Then he employed 8 horses on each hemisphere to pull them apart. So great is the force of atmospheric pressure that the hemispheres could not be pulled apart even with 8 horses pulling on each side. Let's summarize some important points in the whole chapter. Force is a push or a pull acting on an object. Force is of two types, contact and non-contact. The SI unit of force is Newton. Force per unit area is called pressure. The SI unit of pressure is Pascal. Thanks for watching. Like and subscribe for more such videos.